Let's take a look at encoding format of image and videos. It's not the same as encoding. We can see the format in which some image or video files are encoded, right? But we can't know what encoding technique is used. We have listed some popular encoding format here: JPEG, MPEG-4, H.264, or H.265. H.264 and H.265 is a common format in the security industry. Let's take a look at what each of these formats means. First, look at the format made by ITU-T. It is Telecommunication Standardization Sector of the International Telecommunication Union, the maker of H.26x standard. We have here H.261, 3, 4, and 5. We are going to focus on H.264, same standard as MPEG-4 Part 10, which is also called AEC. It's a video compression standard, a widely used high-precision video recording, compression, and publishing format. And then let's focus on H.265, which is also called high-efficiency video recording. The successor to H.264, MPEG-4, AEC, HEVC. It's believed to not only improve video quality, but also achieve twice the comparison rate of H.264 or MPEG-4 AEC. So H.265 is the current trend. So now let's focus on format made by ISO or IEC. MPEG, which stands for Moving Pictures Experts Group. First we had MPEG-1, then 2, and then 4. We focus on MPEG-4 here. So MPEG-4 currently contains 27 parts. We focus on part 2 and 10. So we also mentioned it on the previous slide. MPEG-4 part 2 can be used for network transport, broadcasting, and media storage. It has improved comparison performance over MPEG-2 and the first version of H.264. MPEG-4 Part 10 is technically the same standard as ITU-T H.264, right? The two coding bodies, MPEG and H.26x, eventually collaborated to produce the standard. ITU-T names this standard H.264, which ISO and IEC call it MPEG-4 Advanced Video Code, which is ADC. The next will be concept the bitrate, which means the amount of data per second. And the units usually be megabits per second, Mbps. In the process of video encoding, it is very important to choose a video encode control scheme which is suitable for the scene. Adjusting the video output bitrate is actually a balance between video encoding speed, network bandwidth, and video quality. Okay? Sometimes the network bandwidth is very limited, so it is necessary to give priority to the bitrate and the size priority encoding control scheme. So some of video quality requirements are very high. To high definition video, it is necessary to give priority to the picture quality. And these are two types of bitrate, CBR and VBR, which means constant bitrate and variable bitrate. CBR is to keep the bitrate constant by adjusting the quality of the compressed image, which means we give priority to bitrate, right? And VBR is to keep the quality of compressed graphics constant by changing the bitrate. Down here are common bitrate settings. 1080p 30 Hz frame for H.264 is 4 megabits per second. For H.265 is 2 megabits per second. For H.265 Plus is 1 megabit per second. So, and here is a performance comparison of bitrate of CBR and VBR in different scenarios. In order to facilitate comparison, we tested the average bitrate of CBR and VBR in different scenarios for minutes. If we use VBR in indoor scene, the bitrate is only 1024 megabits per second. And if we use VBR in still scene, the bitrate is only 345 megabits per second. Because the complexity is relatively low in these scenarios, right? Using VBR can save bandwidth. In same scenarios with moving objects such as roads, the VBR has the bitrate of 2437 megabits per second. In some of more complex outdoor scenarios, the VDR can achieve bit rates of 3,507 megabits per second. If you want to save bandwidth in such scenarios, it is best to use CBR, right? Let's now learn some other video encoding technology. So first will be ROI, which means the region of interest. When the ROI is set, this ROI will be encoded with high quality, while other areas are not selected, their bit rates reduced to standard definition comparison. In this way, we can not only focus on information in key areas, but also save bandwidth, right? We have different ROI categories depending on how we classify them, like fixed area ROI, dynamic ROI, or defined by target type, we have phase ROI, license plate ROI, moving target ROI. These two pictures down there shows the difference between seeing with or without ROI. We want to focus the information on this moving object, and we set the moving target as ROI. We can tell if we don't use ROI, the picture size will be 3 megabits. And with help of ROI, we can reduce the size to only 700K. Meanwhile, we can still get details of this moving object, right? So far, the content of our video encoding is all introduced. We learned about the flow of video encoding, what video redundancy is, and intra- and interframe prediction, followed by popular encoding formats as well as CBR and VDR and ROI encoding techniques. Let's now take a look at how audio encoding works and what the difference between it and video encoding. So first, let's learn some basic concepts of audio encoding. The voice frequency here means the numbers of times the voice vibrates within 1 second. Human vocal-oriented sounds frequency range is between 80 to 3,400 Hz. Human ear perception audio frequency range is 20 to 20,000 Hz. There is sampling rate, which means number of voice samples in 1 second. And then is sampling accuracy, which reflects the accuracy of the amplitude of sound waveform, generally expressed by the bits of each sound sample. For example, 24-bit sampling accuracy is equal to it can sample level signals of over 16 million gears of different voltage levels. It can be seen that the higher the sampling accuracy, the higher the recording quality, the richer the recording details, right? From the basic concepts above, we can see the audio, like video, also has a concept of frame and frame rate and bit rate, right? So after some basic concepts, let's have a look at the basic concepts of audio processing. Mixing here means we mix different sounds together to create an audio stream. Audio decontamination is a technique that can remove ambient noise or circuit noise. Also, we can adjust the volume by volume adjustment. Audio output here means the audio data is converted into analog signals and the real sound is output through media such as speakers and earphones. And last is the audio encoding, which means compress PCM data into encoded data for storage and network transmission. In audio and video, PCM is a method of sampling analog signals by digital signal representation. The input data that we are going to talk about for audio encoding is PCM data, okay? With the basic knowledge of audio processing, let's take a closer look of the steps that we should take. Like in the flow map, from the very left, we can see the input data up to PCM audio data, and the encoder will mix them by audio mixing algorithm into one PCM audio data. This is the mixing technology which we learned before, right? And there is something you have to know is that PCM data is the generally processing format of audio processing chip. The above functions we said before, such as audio mixing, need to use PCM data for processing. So through encoding, the bit rate of audio can be reduced. Usually our encoding is the process of converting the PCM raw data into coded data. Like the example down below. The encoder encodes the PCM data into G711. G711 is a set of voice comparison standards customized by ITUT. It represents the PCM sampling standard, which is mainly used for telephone. Decoding is also the opposite, right? It's easy to understand. So that's all content for today's course. In this course, from the beginning, we talked about what is encoding and why we need it. Then in the video encoding part, we learned the complete process of encoding. First, we use encoder to compress the data, for example, into H.264. Then encapsulate the data into PS and RTP stream, right? So also we learn different types of encoding technologies like intra or inter-prediction, VBR, CBR, and ROI region of interest, right? At last audio encoding part, we learn some basic concepts of audio encoding like sampling rate and sampling accuracy, right? Then at last, the audio processing first mix the PCM data, then convert data into encoded data like G711. So thank you for your listening and hope we can meet again.